Hello and welcome to my talk, Hidden Peels for the Java High-Performance Persistence. I just finished my slides and we want to talk a little bit about maybe unknown open source frameworks, a tool that you can use to implement persistence straight away inside your JVM without external processes. We will have a look at the pros and cons and some tiny implementation details. And yeah, that will be covered by this talk. But it's late now, my slides are just done, this background is boring, so I want to take you with me to two journeys. First of all, the journey about this embedded persistence, and the second journey is to the German forest. And for this, I will prepare my stuff for tomorrow, and see you in a second. So, I found a decent place in the forest, and well, let's start with the first question: why and what? So this talk is focusing on high-performance persistence, or on persistent solutions that can be first embedded inside the JVM, and I'm addressing this environment where just a handful of users inside companies need an application dealing with, let's say, terabyte of data, 2 terabyte of data, or maybe you want to have something that you can use in IoT devices, embedded systems, something like this. So the solutions I'm looking for has different points I want to reach as near as possible at the JVM or inside the JVM. It should be lightweight and efficient for different areas, topics we want to cover, from key value to document store or whatever. And I don't want to focus on the well-known big applications or frameworks we know. I want to give you some ideas what other open source frameworks or free-to-use frameworks are available and in the field, so that you can just try them and decide if this one is for you. So, we are not covering Kafka, we are not covering Cassandra, we are not covering all this stuff. So many other talks available about these huge scalable systems. I want to focus on scaling inside the JVM, having an efficient and innovative way of storing data. So, and for this, let's start. Okay. It's cold. No, it's not cold. It's a little bit fresh, but it's a perfect time to make a coffee. And during this time, I want to explain a little bit about existing solutions that are in the market or in the field since a long time, and why they are half fitting to this topic, but not completely fitting to this topic. Let's say we have now the possibility to to change something inside a legacy project. One thing that's mostly not changeable is the persistence layer itself. So there is an existing SQL store, for example, and the SQL store has the challenge that there's a lot of data, there's a lot of history, and this is a leading system, and you can't just get rid of it. But what can you do? We have several approaches to improve performance or convenience, and I will show you three solutions. And these three solutions are more or less the beginning of optimization. But what's the optimization? The main optimization. So now I try to make fire. Okay. So the main optimization here is that, for example, if you're looking at this open source tool or partially open source tool called Juke. Juke is something that's quite long in the field, and the Lukas Eder, the inventor, is quite active in the community. I think a lot of you are knowing this tool. So the main thing here is that what he is doing? He is assuming that there is an existing data store, and this is a leading one, and this is mostly the single source of truth. And from this, you're building all this stuff up. I missed my cup a second. Okay, so I found my stuff here. So I needed my cup, otherwise it's just burning here, and there's not really. So here's better. So the main thing is that if this is a leading source of truth and you're not able to get rid of all this stuff, what are the possibilities to speed up for higher performance? So higher performance is based on the system itself, and what Juke is giving you is it's an Java API on top of SQL, or it's an SQL Java style SQL. So you can have higher performance with this one if you're using this one very efficiently, because what you can do is just you can write very optimized SQL itself, but you're still on SQL. So we're not getting rid of this additional layer. We are not getting rid of JDBC. We are not getting rid of this schema transformation to SQL style. So all this stuff, but we can optimize the SQL itself. But we have to deal with the SQL. So what's the life cycle? The life cycle of this is that you're generating this Java classes based on the database schema, and from this one you are start typing your SQLs. And if you're looking at this API, I will show it here somewhere. You will see you have an API like select, from, limit, where, whatever. So it's really SQL style. But the whole performance optimization volume you can have is the knowledge of SQL. So the tool is not supporting you in terms of making something faster per default. It's just giving you the possibility. So this is one thing. Then if you don't want to deal with SQL, the next possible tool that is nearby, it's called Speedman. Speedman is open source for the most open source database systems, and it's not open source for, I think, DB2 also. But MySQL, Postgre, and all this stuff is for free and open source. So what they are doing, they are saying, okay, a Java developer don't want to deal maybe with SQL, or he has not the potential to deal efficiently with SQL. So you want to support the developer in a way that they say, you have streams with Java 8, and with the streams you can write down what you want to have. So select from cars, filter, compare, whatever, map, and so on and so on. So what they have done is they took the streams API and transforming this one to SQL. Again, they are assuming that the database persistence layer itself is a leading one, the only leading one, the single source of truth. They are generating a lot of Java classes, and then they will give you the streaming API. The streaming API itself, it's convenient, it's more Java style, so the adoption rate could be quite high here at this point, but the whole life cycle from Duke as well as from Speedman, or another tool is Query DSL. It's again an old tool, but it's just generating stuff, then you can use it. So the whole life cycle, the whole test-driven approach is not so nice because you have always this generating stuff, the schema transformation and so on. You can do it in both directions, but this mapping is not very convenient. Then there is a sub-project from Speedman, and here what they're saying is you have already this mapping, for example with Hibernate, and they are setting on top of Hibernate the streaming API. So JPA Streamer is open source as well, it's on GitHub. And what you will find here is a streaming approach, and then you don't have this generating classes stuff because they're assuming all this stuff is already done by the JPA layer or lower with the Hibernate stuff. And what you will get is again a stream API, and you're using here stream off, and then you have this entity classes. So all these approaches, what they are reaching here, and the interesting thing is that they are focusing on convenience. The next thing I want to look at is something that is immediately inside the JVM. The next step is we want to get rid of all generating processes. We want to get rid of this over-the-wire communication and these external processes, because there is a huge potential for speed up. So, and this will take some time, but the next step we want to look at is Chronicle Maps and Bytes. So it will take some time until my coffee is ready. So I will use this to explain a little bit what is the first solution that is getting rid of all the existing layer. And this is a solution that is coming from high frequency trading. This is from the, I think, London stocks market. The inventor is Peter Lorre, and they need something with really low latency. And the focus here on what I want to explain is for the need to dump down data as fast as possible, like logs, transaction logs or events or whatever. I'm talking here about Chronicle Bytes. You will find it on the GitHub account. It's open source as well. So it's an organization, it's OpenHFT, and the project is Chronicle Bytes. So with Chronicle Bytes, what you have is the possibility to write very compact data down. So it means you're writing bytes, ints, chars, whatever. And here, the first thing you're adding this dependency, it's net OpenHFT, and the artifact ID is Chronicle Bytes. And then you have the possibility to go via this class called I have to check it here because I can't remember every class name exactly. It's called Bytes, and Bytes has some different possibilities to create these maps, or these buffers, byte buffers. Here we are talking about byte buffers, and one is, for example, elastic heap bytes buffer. Then you can say this amount of memory I want to have for this one. This is a pure memory one, and then you can do the same with the mapped bytes, the class mapped bytes, and then you have this factory method called mapped bytes. Here what you're doing is you're pointing to a file, and then everything you're writing with the methods append UTF-8, append byte, append whatever, it's just dumped down to disk. So what is the target here? The target here is to have a very fast solution to write very compact data down. So if you have your business model, what you need is that you have to decompose this in different attributes. So a class with two attributes, maybe an int and a byte, will be just one append with an int, one with a byte, and the next one is again an int and the byte. So what you need to deal with this is you have to decompose a class to the sequence of data types you're writing down. This is a very compact way, so all the people from C, C++ and so on, they're used to it. We in the Java world, we are not really used to it, but the same is if you're reading this stuff, you're pointing to this directory, you say, okay, this is exactly my map to bytes, and then you're reading an int and string, an int and boolean and whatever. So, so you have to have in mind that for writing and reading, you have to decide in which order the attributes are written down. And this you need to know. So if you're just reading something different, then it will be just crap. So what's the solution for? The solution is for if you really have to write down as fast as possible and as compact as possible, just pure data types. So, but you're losing at this point the information about the class, the composition, and what you are not able to do is to build relations between class. So this class with attribute ABC has a reference to the other class with attributes ABC. So you really have to dump down this data in a very straightforward way. So now I hope it will take some time. So the next thing what we want to look at is chronicle maps. Chronicle maps is in-memory, non-blocking, key-value store, designed for low latency, and so on and so on. So you can read it in the GitHub repository as well. So what we have here is the next convenience layer. So with the bytes, we are losing the context of the class, and we are just pushing down the core data. With maps, we have a persistence data structure, and again, what you have this dependency net.openhft, and the artifact ID is chronicle minus maps. So what we have here, we have this class chronicle map, and then you can say, I want to have a map of type A and B, so of a key class, a key type, and a value type. Here, what you should have in mind is that at this point, you have to think about the serialization process itself. So the solution will give you the possibility to have a key value store, but you have to make sure that key as well as a value is in a way serializable. And the next thing is that you are giving this map a name, so you can have different maps, and every map will have an identity. And then we have a few interesting, not really, this approach is not common for the Java world. So you have to think about the amount of entry. This is something, but the new thing is that you have to think about an average value. So the internal structure of this map is built on this param, not only how many values you are expecting, it is based on the average value. So if you have as a value an int, and this is mostly something between 1 and 10, then you would say the average value will be a 5. But the same with char sequences, with bytes, with bytes is not so, but with all other types you want to write as a value, you have to think about an average value, and this will internally calibrate the map and will influence the way how this is managed. If you have this factory method, so you say chronicle map of key and value type, you will give a name, then you will say I am expecting 50 entries and the average value is whatever. The next method is create persistence 2, and again you're just giving a file name. And the good thing is that if you want to back up and restore this stuff, you just have to make a backup of this folder or this file, and then you are done. So what we have here, we have really low latency possibility to dump data down. We have bytes, we have maps, there are some other projects around, so they are focusing mostly on this core data structures, not on compositions of data structures. You have to think about the serialization process itself. There's a possibility of sharding and all this stuff, so for this read the documentation. But the main thing is that we have now an in-memory, an in-JVM solution. We can just dump data down, we can read it very fast, we have to decompose to generic types again. And so the next thing I want to have a look at is something that will give you more convenience in terms of compose this data. So instead of just having pure data structures, I want to have something that is more in terms of there is a schema, there is a relation between different things. And for this one, we will have a look at the next implementation that's open source as well, and this is called Exodus. I just love it. A fresh cup of coffee in the forest, nobody else here, just perfect. So, the next thing I want to talk about is Exodus. Exodus is from JetBrains, this company that's creating this amazing IDE called IntelliJ, and they have really good engineers and some other products. In their products are, for example, UTrack is an issue tracker and some other stuff around. I don't want to talk about the products, but for their products they needed something that is dealing with persistence. And we will see here that they needed something for the issue tracker, and an issue tracker is just a bunch of attributes called an issue, and then you have to link stuff in between. You want to upload in PDF, so you have to deal with binary streams. So it's quite a complex persistence structure you have, and for this they created this open source tool called Exodus. Exodus is an exit compliant, so you have transactions. It's based on MVCC, and it's just dealing with snapshot isolation, strong snapshot isolation. So all changes will be written in transaction log. I think they have these files are something XD files or whatever, and they're immutable. It means you have something like a functional, immutable, persistent data structure, and this is just amazing. You can completely embed it, so it's an embedded solution. This is why it's in this talk. It's written in Java and I assume in Kotlin as well, and it's Apache 2 license. The only downside here at this part is it's not a product, it's just a project from them, so you can't really buy support for it. But I think if you have an issue and you're creating something on GitHub, you will be in contact quite soonish. So this project is under active development. What we have here is we have now a schemaless transactional database, or persistence layer, or whatever you want to say. And this is quite cool because we have now this possibility to have a bunch of attributes. They are together in called entities. I will cover this one in a few minutes. And then you can link them together. And we have so everything, or we have a higher convenience layer that we had with the previous ones. We were able to write bytes, or we had these hash maps, and they have this in 3 flavors, and I want to describe every single flavor by themselves, but they have one dedicated API on top of it. So on GitHub you will find it under JetBrains/Exodus, and then you have this API. This is the dependency. I will write it somewhere here. And then you have the 3 different dependencies. It's an environment, it's a virtual file system, and it's entity store, I think. So, but this we will cover in a second. The first thing I want to cover is called environments. Environments is the lowest level of abstraction they are offering, and again, for all layers I'm explaining right now is that this immutable data will lead to still or strong monotonic growing logs normally, so you need something like a housekeeping. Don't worry about this one. This housekeeping is done in the background by the engine itself. So I just thought about it because it's an immutable data store, but housekeeping is done by itself. So after you added the first dependency, it's called this Xodos minus API or Open API. I think it's Xodos minus Open API. You have the possibility to add an implementation for this API. One is called environment. Environment is a transactional key value store, and you have it in two flavors. One is with duplicates and one is without duplicates. So it means you have a multi-map or you have a hash map. So how to deal with this? So I'm now reading here because I can't remember all this source code. What you have here is that you have this environment and you're creating a new instance. This new instance has a param that is leading to a directory. Inside this directory, you will have all this data. Inside this environment or with this environment, you're creating a transaction. Have in mind that everything is strong transactional in this environment, so everything must be wrapped inside a transaction. So this API will give you always this inner classes or this anonymous class you have to implement. You get used to this one, but on the other side, it's really a straightforward way. It's just pushing you always in the right direction, and that is, I think, it's a very good thing. So you have this executing transaction. You will get this transaction entity that you're using for different commands, and then you're opening a store. A store will have a name, so you can have multiple stores. You have to give them names, so this is the entity, and then you have to decide if this store is with duplicates or without duplicates. It's more or less like this chronicle maps with an entity about you have a map with a name A or B, or with MapDB it's the same, or with others. So it's a lot of solutions that will give you some kind of persistent data structures or stuff like this, or Hazel cards, for example, is doing the same. They have this data structure combined with a name, so that it's their way to give it an identity. Here, the same. So and then you have this store, and inside this store you can just put and remove and all this stuff done. The only thing you should have in mind is that you have to think about serialization itself. So the key and the value must be somehow serializable, and they are offering something. Otherwise you have to think about how to serialize and deserialize it. And this is one of the drawbacks that is mostly with these toolings, that you have to deal with the serialization issue by yourself. So I will show you a solution in the end that is getting rid of this, but so far Xodos itself is dealing with this serialization. And yeah, that's it. So you have a key value map with duplicates, without duplicates. Entity stores. The next one are entity stores. So we had now this key value pairs. This is the lowest level from this Xodos API. The next layer on top of it is called entity stores. Again, you're adding the dependency for entity stores. I will show them somewhere here. I'll read it in documentation. And the next possibility, or what is the point of this entity store is that you now have the possibility not only to have key value stores or key value pairs. The next thing is that you have now entities. Entities can have a bunch of attributes, and the good thing is that you have the possibility to link entities. So now you don't have the single maps and you have to link them by yourself. You have entities, and entities can be linked, so you can start building lists, trees, graphs, whatever. And the good thing is the API for modifying, creating, deleting stuff is there, but you have now the possibilities or way more feature-rich API about query data, or to query data and to select stuff and so on. Again, what you're doing is you're creating this environment. From this environment you're grabbing a transaction, and then from this transaction you say a new entity, you will give it a name, so think about a scaling naming schema, and then you can set these properties. and adding links and all this stuff. Again, you have to think about serialization itself, and so far this layer is not mentioned to use with binary streams. So this is something I will explain in a minute. So here we have now the full possibility to have a schemaless user or a schemaless model that can be refactored on the fly, that can be used for a business model already, because you have these entities and this possibility of linking. So this is quite convenient, and have in mind everything is strong transactional. And yeah, the last thing they have in their API is something that is dealing with binary streams. So the last part of this Xodus API is about the virtual file system. The virtual file system itself is to deal with binary streams. So have in mind it's coming from issue tracker, so you have this bunch of attributes, you can link them, and then you have attachments like PDFs and whatever. And for this they created the virtual file system. So again, you're creating this virtual file system, you're pointing to a directory where all these files should be stored, so the store itself. And with this one, you're creating the virtual file system, you're creating a transaction, and inside this transaction you can now deal with this byte stream. So reading, whatever, appending, also reading, appending, creating, and so on. So all this stuff is done with a virtual file system. Everything together is now quite powerful combination. So if you have the possibility just to have transactional key value pairs, you have the possibility to have these buckets of attributes and link them. You can deal now with binary streams and storing them. So everything together will give you a whole persistent system that you can use for so many different things, and they are strong transactional. One thing, they have some performance benchmarks, and they are on their own homepage. So I'm not measuring this one, I'm redirecting to these values, and it's really interesting to see how they compared, especially Xodus to Chronicle, to MapDB, to H, whatever, and Berkeley, and so on. So they have different performance benchmarks. Have a look at this one, and you see that all solutions I'm presenting here right now, they are more or less in the same category. So they're not really compete, or there's not a clear winner, but you can really use them all as a very performance solution. But you can choose based on the functionality and needs. And the next thing is something really, really interesting, because we have now the possibility just to dump data down. We have these data structures, we can link them, we can deal with binary structures. But there's one thing that is really interesting, because so far we are not able to cascade data structures with different behavior. And there's a tool that is exactly able to do this one, and this we will cover as next, and it's called MapDB. MapDB is from Jan Kotek, and it's on GitHub available on Apache 2 license, and it's under Jan Kotek /MapDB. Otherwise, just search for MapDB and you will find the homepage, the documentation, and so on. I think the most documentation is on GitBooks, or it's called, whatever. So what does it mean, or what is the unique thing, or how to use this one? So MapDB itself is a combination between database engine and Java collections. You can use this collection as drop-in replacement. This is really convenient, and it's written in I think right now in Kotlin. So what do we have? We have now data structures, and he will offer you transactional behavior. So we have based on MVCC, so data structures with commit and rollback. To start with this, it's a Maven dependency org mapdb, and the artifact ID is mapdb, and then the version. During the time I'm recording this talk, it's a version 3.0.8, and this is since a long time. So this is a very stable project. It's a quite old project, and he is really taking care about backward compatibility, so between major or between the data that is stored. So with the next major upgrade, you can read the existing data. So this is good. But implementation of the version 4, so he's planning now since 2 years, the version 4, and I can't really see any progress. So we don't know if this is a maintained project during the next years or with a new major upgrade. But the good thing is, if you have some issues, you can hire him. He is, I think, working as a freelancer, so, but he is explicit giving support for this one if you need it. But have this in mind. So if you are dealing with this framework and there is no issue for you, or you are not waiting for new feature, this is a very rock solid implementation. So what does we have? We have the data structures, and we have them in 2 flavors, off heap and on heap. So here again, if you're going off heap with implementation, make sure that you're really testing the JDK you're using together with your implementation. Just have in mind everything that's going off heap is critical. If there's any exception, then the whole JVM is just blown away. Okay, so it's a data structure, so you have lists, queues, maps, and whatever, say inside. And I will focus here on the hash map. The hash maps itself, you have different implementation, concurrent tree maps and whatever. And you have them in 2 flavors regarding this place where data is stored. It's a pure in-memory solutions, on-heap, off-heap, or you have on-disk solutions. And the really nice feature here is that you can cascade it. So let's focus first on how to create one. So the first thing after dependency, after you added the dependency, is that you have to deal with this DB maker. So this DB maker is offering some factory methods to create the official or the first DB, and inside this DB you are storing your data structures. So that's a way I think nearly every solution is doing something like this. So here this DB maker has a possibility to create a file DB or a memory DB, and if you have the file DB, you are just adding the location folder where MapDB is storing all this stuff. And again, backup and restore is quite easy because you can just make a tar gz from this folder and that's it. Then you have some special features like encryption, for example. Oh, by the way, I think encryption is available for Xodus, is available for MapDB, is available for, well, at least for this 2, you have the possibility to encrypt the data itself. So, for example, if you're using MapDB on embedded devices also. And then you have this DB. If you want to have this DB, then you are invoking the method that will give you the corresponding data structure. For example, here the tree map. And again, if you want to have a tree map, you have to offer 2 params, at least 2 params. It's one is the name of the map, so the entity, and the next one is the key and the value serializer. So it means you have to take care about how to serialize this data. You can use different serializer, for example Creo or whatever, or you can use a built-in serializer. This will give you the freedom on one hand to store quite complex attributes as a value, not just core data types like int, string, whatever. And on the other side, you have to maintain this serialization issue here by yourself. If you have this one, then you can create or open this map, and with this map you can just have put, get, compute if absent, and so on. And if you want to have this transactional behavior, you can do something like put, commit, then it's persistent, or roll back, and then the map is again in the previous state. So this is very convenient because you have a very powerful tool for dealing with concurrency. But the good or the unique feature here is not only the transactional behavior, it's this cascading of data structures. So how this is done. You can create a map that is just in memory. And then you can create a map that is on disk, and then you can combine them. So how to do it? First, you are creating a DB in memory. Then you are creating a DB on disk. From the DB memory, you are grabbing a hash map but first you have to grab a hash map from the DB on disk. So how to combine them? If you have this disk or this hash map that is storing or persistent on disk, then you can start creating the memory solution. And here you're just going the way that you say, okay, create this hash map, and then here you have, I have to read it a little bit because it's too much source code. So the first thing is you're creating this hash map, and then you have the possibility to say something. You can configure the eviction algorithm. So how long it will take until the eviction algorithm is active. You can say something like the work of this eviction work will be done by this dedicated executor pool, and so on. And you have the method expire overflow. And this method expire overflow, that will give you the possibility to put another data structure in. It could be other memory data structure or memory-based data structure, or it could be this file-based or this on disk persisted data structure. And this is very cool. Now you have the possibility to push data into the memory implementation, and if you're writing commit, it will be committed of all layers down to disk. You have the possibility to put data directly to the disk hash map at the same time and committing, and then it's persistent, and the first request on the memory will load it to the memory representation again. So you have the possibility to write and modify on all levels, and you have on all levels this commit and rollback behavior, and with this you can build quite easily caching architecture or memory managed architectures. For example, you have an embedded device, you have just a sliding window of hot data, and you want to hold this one in memory, and the rest is just on disk, and so on and so on. So this is the only solution I know so far that will give you this easy and powerful implementation on core data structures that you can use as drop-in replacement with this overflow, with this eviction algorithm, and with commit and rollback. So have a look at this one, try it out. This is called MapDB, and it's available on GitHub. So I just love the forest, so you can just go everywhere and take some time. Perfect. So, but we want to talk now about a game changer in the field of persistence, and why. So the tool I'm talking about, or the framework or lib or whatever you want to say, it's called MicroStream. It's from a tiny German company. They just got their seed funding. They're working on this idea since, I think, 5 years or 6 years. So they used it for consultant first. They proved all this stuff they had, and then they decided to make a product out of it. The thing here with this MicroStream is that we have the possibility now to store object graphs without decomposing it. So again, we are addressing exactly this field of inside a JVM, just targeting a folder where I want to store all my stuff. And the good thing is that I don't know how they have done it, so my research is not done with this so far, but they implemented a different kind of serialization. And this is not based on the core Java serialization. So it's not the same solution like all the other tools that try to make this a little bit more performant or whatever. So they found a way to completely do it in a different way. Well, the main thing is that you will add this dependency. I will give you the link somewhere here, and then you can use it for free. So far it's free to use. It's until now not open source, but I got the information from the CEO that there is some planning that it will be announced soonish that it will be open source. So the announcement is already done. It will be open source, but until now I have no timeline. So it's an open source tool more or less in the near future, and then let's see how they have done it. So I'm really looking forward to analyze it more in detail. So if I have any researcher here in my audience, please have a look at this and let me know what you find out. But how it's working? You're adding this dependency, and then you're creating this entity store. You're starting it. You have different possibilities. So as soon as since a few weeks they have the possibility to persist just on disk, or you can use it on top of other persistence layer. But we are focusing now on I'm storing on disk, because this is a main topic here in this talk. I want to have something embedded inside my JVM without external processes. So you're starting this entity store, and then you have to define a root. A root is the root of your graph. And for example, you have this this car with engine and wheels and whatever. You would take this car and set it as root, and then just say save. That's it. So during the time I saw it the first time, I thought, oh, this is something like DB4O, or what it's called. It's long time ago. And with these solutions, I know from the past it was more or less that every entity must inherit from something or must implement some interface or whatever. And here it's just not the case. Even with new data types like records and all this stuff, it's just working. So you don't have this push to some inheritance. You don't have this push with some marker interfaces. You have just these core data structures like maps and lists and queues and int and byte and whatever. You can compose whatever you want out of it. So your use case or your business model, and then just say save. The only thing, of course, that's not persisted is something like streams, but streams are not data structure. So this is okay. So if you want to have more than one car as a root, what you're just doing is you're declaring a list and then putting all cars in and saying this is the root, this list is the root, and then say save. I tried a few things. First of all, I tried just a class, and then I stored it and loaded it, no challenge. Then I built a list of class A is using class B, is using class C, so as attributes, and storing in, loading it, no challenge. I built a tree and stored it and loaded it, it's not, and I created graphs. So I created rings, cycles inside, and in this it was easy to store and to load. So there was no challenge. Even if I have a graph and I say one time this is a root, loading, storing, and then the next time I'm declaring something else and storing it in a different way. So even this was working properly. So my conclusion here is that if they really found a new way of serialization, then it would be great, because you would get rid of all the security issues as well. I try to break it. I have some articles on DZone about it, and I will create on my YouTube channel soonish a few videos about this topic, because I want to have a more detailed look at this one. I'm just testing it in different implementations, because it's fast. It's really, really fast. So I just have my graph and say store, and it's stored. So fantastic. So this is one thing I really want to highlight here, that this is the only solution compared to the other ones, that I don't have to decompose my business model. I don't have to transfer it in classes that can be serialized. There's no need to have different inheritance things or whatever. So even if you have a class, if you have a immutable class like just constructor params and then getters, it's not a challenge. If you have getters and setters, it's working. If you have, so whatever you're doing and whatever inheritance combination you're doing, it's just working. So have a look at this one and try to break it. Really, please try to break it, because I want to have feedback not only from my side, from other people, if this really a game changer in this way. So this is one thing. So in general, what I can say is you're adding a dependency, you're taking your graph and you're just storing it and loading it. How to deal with big graphs. So for example, if you have a huge graph and you don't want to have everything in memory at once, there is one thing I I personally, I think it's not nice, but I can understand that they are doing it. That you have to build these parts where you say lazy loading is allowed at this level. So for example, you have a class A, class B, class C, and you want to have lazy loading for the last step for class C. If you're loading class A, then you have to wrap this attribute in a lazy reference. It's more or less a virtual proxy, and then only if you're accessing this or if you are grabbing this attribute, then it will be loaded from disk. So that's all. Otherwise, you have different configuration possibilities and all this stuff. So for this, check out the documentation. But in general, I saw this is a very convenient one. So yeah, that's it to MicroStream. Oh, by the way, there is one thing. MicroStream is just offering a hackathon, and this hackathon is running from now up to something in February 2021, and they have high prices, like a few $1,000 for the first 3 or 4 winners. So check it out, this hackathon. If you have an open source project, or if you want to run it on Graal or with Helidon or whatever, you can have even additional prizes. So they are working together with a Helidon team and with a Graal VM team. So MicroStream is working on native images as well. So, well, have a look at this one, have a look at this hackathon. If you want to have more questions, just come to me. And yeah, that's all to MicroStream so far. Okay, we saw now different solutions, but there are a few things that are you should have in mind for all of these solutions or other solutions you're grabbing. So if you're talking about in-memory persistence, compared to something that is going to traditional persistent systems. For example, if you're dealing with Juke or Speedman, what you can do is you can use SQL tooling to go to the original database and then manipulate this data, making a backup, changing stuff, the schema, whatever. So this is easy. But how to do this with all the other solutions? One thing is that you should have an eye on backup and restore. All solutions I showed you, they have the possibility that you're just shutting down the environment, you're making tar.gz of this folder, and then you're done. That is good because you can use this one for the TDD phase as well. So if you have just a tiny tar.gz you have in, for example, in generic repository, let's assume you have an Artifactory there, you have this generic repository, then you can have this test data inside this generic repository corresponding to the version of your program you're developing. So this is easy. So on the other side, you have to shut down the system to make this copy. Sometimes it's possible, sometimes it's just not possible. So for this, check for every solution if they have the possibility to make backup on the fly. For MicroStream, for example, it's very easy. You have this backup strategy, you are invoking it, you're making a backup, that's it. You have the same possibility, I think, for Xodus, and you have the possibility for MapDB, Chronicles, Maps and Bytes, I'm not sure. So, so far what I was able to read is that you just have to shut down the corresponding hash map, and then, or you're exporting to a dump during the runtime. So you have this possibility, check what fits to your needs. The next thing is you have to deal with dependencies. And the good thing is you're removing the amount of components. So if you start, for example, with vulnerability scanning, you don't have to scan the database layers, this operating system layer, and so on. So you can focus on just scanning the dependencies. If you want to have a look at these dependencies and known vulnerabilities, you can go to JFrog.com. We have this free tier now, and this free tier is includes X-ray part. So X-ray is a vulnerability scanner, and with this you can scan straight in your IDE, for example, the vulnerabilities of all dependencies and transitive dependencies. So have a look at this one, because everything that's persisting somehow, or the most solutions, exceptional the MicroStream, this is not dealing with this one, but all other solutions are dealing somehow with a classical serialization part, and this means that quite often you have vulnerabilities there. So have a look at this one and check this one, so the whole tree. This is okay for the vulnerabilities. On the other side, if you want to have this vulnerability scanning, or if you found something, the best safety build against this one is a good test coverage. So again, you want to have a good test coverage to fight against vulnerabilities, to have a validate use case, to have high quality. So everything is working hand in hand. Getting rid of these additional layers means that you have a way easier life cycle, how to manage a little bit more complex life cycles. For example, have a look at my YouTube video about JUnit 5 custom test engines. There you can manage, for example, quite complex or other life cycles that are not so easy to handle with a classical vintage engine or the Jupyter engine from JUnit 5. But test coverage is your safety build. Here again, so all will give you the possibility to ramp up, ramp down very fast the persistence layer. So this is easy and convenient during the development time. And then you can use, for example, not only line coverage, you can go over mutation testing or with mutation test coverage. This is a really strong way of creating a test coverage report. If you want to have an idea about mutation testing, I have a talk about mutation testing on YouTube, so check out my channel, subscribe it please, and have a look at my mutation testing talk, and then I will explain what's the difference to line coverage. But everything together means that if you can focus on embedded persistence, you have a lot of benefits. So you have a very fast TDD cycle, you have the possibility to easily have a data-driven testing approach, and so on. The only thing you should have in mind is how to deal with toolings, ad hoc toolings, browsers of the data, and so on. For example, Xodus will give you an object browser. For Chronicle it's not available, for MapDB it's not available, for MicroStream I think they have something like this. So whatever tool you're choosing, have a look at this tool stack, have a look how to make backup and restore, how to deal with vulnerabilities, how easy it is to ramp up and ramp down the whole TDD cycle. So all of this will affect the performance during the development time, the performance during the runtime, and the convenience to maintain the systems. So that is more or less everything I want to say about the DevSecOps part. Oh, there's one thing I want to highlight. DevSecOps or DevOps, whatever, if you are testing the system and you're dealing with serialization or with binaries you're storing and loading, it's very good advice to have a look at security payload testing. Security payload testing means that you're creating compromised binaries. It could be corrupted data, it could be compromised in the way that you try to invoke external processes and so on. There are different aspects here, but security payload testing is deal with corrupted data against your persistence layer and see if everything is running well. So that's it. I think all other things are clear in the terms of DevSecOps, DevOps, so you have the possibility to have a really straightforward way to maintain your development cycle, your production cycle, and so on. Okay, so we had all things I wanted to say. So now it's time for the conclusion. So what should we learn out of this one? So the main thing is that we have different solutions, and we can choose the level we want to have as an entry. So if we want to have more convenience, then we can go with Duke, QueryDSL, Speedman, JPA Streamer. Every time if you want to have something that must fit on the existing persistence layer, they are all open source, at least partially. And the power here is that you have to tweak, for example, the SQL commands, or you have to tweak this Hibernate layer or whatever. So if you can get rid of this layer, a huge big potential is now available for you if you're talking about one machine, because you can now get rid of this communication and external process stuff, not only in terms of DevOps, in having way easier life cycles that you can ramp up, ramp down, your TDD phase is faster, and so on. On the other side, you can just choose the layer you need. If you want to have something that's just dumping down data as fast as possible, something like transaction logs, events, whatever, go with Chronicle Maps, but it depends on the level of convenience you want to have, or on the way how compact you want to have your data. So this is one level. If you want to have something like more entity or document store oriented layer, go with Xodos. You have this transactional behavior here. You have the possibility to have a bunch of attributes linking together. You have a convenient way to deal with binaries, and everything together can be very fine-tuned, and it's very strong. You have this immutable data store. The next thing is that you can go with cascaded data structures if you need something like this, and to persist this one with MapDB, you have this overflow mechanism, this eviction algorithm that's going over dedicated data structures. You can have commit rollback here, and this is very convenient. If you want to have really the full power of a new serialization framework, go with MicroStream. You have the full potential of just storing graphs. This is the youngest project here. You can expect that there will be an active development, because this is company driven. MapDB is driven by one guy. Xodos is a sub-project from the product development of JetBrains. Chronicle is a tool that Chronicle or Peter Lorre is using for this consultant work. So you have different flavors, you have different possibilities of getting support. It really depends on your project, what's convenient for you. But all of these solutions that are focusing on running inside the JVM, persisting locally, you can combine with other techniques like Hazel cars or whatever if you want to scale over different nodes. And they are really fast and give you a very focused way of storing, manipulating, querying, and whatever data. Have in mind that they have different toolings, so this is just one thing you should have in mind, how to deal with data manipulation, data navigation, ad hoc querying, and all this stuff. Everything together. Thank you very much for attending this talk. I would really appreciate if you would be my next subscriber on YouTube, because there I'm handling all these different DevSega, persistence, core Java, functional Java, and other topics. So have a look there. I would really appreciate to see you as my new subscriber. If you want to reach out to me, you can use every time Twitter, LinkedIn, whatever is convenient for you, but don't use email. Please don't use email. This is very important. So, yeah, that's it. Thank you very much, and see you soon.